Okay. Ciao a tutti. And wow, it's really, really cool to be here. And I want to thank BlueHat, sorry, for giving us this opportunity. It was really a mistake. Really, it was a mistake. It was not intended. For giving us this opportunity and for this amazing event and even more amazing location. Okay. So I didn't see the video, but from what I understand, they know much more about me than myself. So I will skip my boring presentation. Antonio, if you have something more to say.
Hi, everyone. Can you hear me?
No.
Hello? You got it. Hi, everyone. I'm Antonio Cocomazzi, and I'm a threat researcher at SentinelOne. I mainly deal with malware analysis and reverse engineering, and in my free time, I use those skills for offensive purposes, so like coding offensive tools and finding vulnerabilities. On the right, you can find my public channel, you can find my Twitter account and my GitHub account, in which I often publish my updates about research and tools. Back to you, Andrea. Okay.
So, first of all, why this talk? May I ask you a question? I don't like to do it, but it's important for us to understand. How many of you know NTLM relay? Wow, great. Everyone knows it. Okay. So why this talk about NTLM relay? Because, as you can imagine, NTLM relay is well known. But when we consider an NTLM relay, we always take in consideration the classic protocols, such as SMB, HTTP, LDAP, and so on. But what about RPC? Because RPC is a protocol which is heavily used in Windows and to support the inter-process communications for COM objects and so on. And the interesting thing is that RPC calls are always, or very often, authenticated, which exposes to a particular attack surface, which is to relay the authentication, because RPC can use different authentication mechanisms, such as negotiate or NTLM. And NTLM is of our particular interest, because if we are able somehow, in some way, to perform in a man-in-the-middle attack, we can relay authentication to other services and other servers. And the final, last but not least, that DCOM and there are some DCOM and RPC triggers which do not require user interaction. So this is the agenda. Very short, I promise it, very, very short introduction on the basic concepts like RPC, DCOM, and NTLM relay. Then we will go to the juicy part, where we explain our research in NTLM relay, how we perform cross-protocol relay and cross-session relay. Then we will show you some demos, and according to the time left, maybe 2 or 3, okay?
See.
Hope it, finger crossed. Finally, the mitigations and the conclusions. Okay, let's start with the basic concept. So, what is RPC? Well, everyone knows it, but it's just a technique which permits a program to call a procedure which is running in a different address space. This can be on the same machine or over the network. And when we are running RPC over the network, we use some protocols such as TCP, UDP, name pipe, HTTP, SMB, and so on, or a local procedure call for inter-process communication. MSRPC is the Microsoft implementation of RPC, and it's very, very heavily used. It's a client-server model. As you can understand, I am very bad in English and even worse in spelling, so it relies on this library, and I won't spell it, okay? The remote procedure is exposed via interfaces, which are defined by a particular language, the IDL, Interface Definition Language, and compiled via a particular compiler. there is another important service, which is the endpoint mapper service. Think about it as a DNS, which permits to identify the interface of the endpoint where this interface is running, okay? So that we can contact the remote server based on server address, protocol, and port. In the screenshot, you can see with this utility port query, all the list of the registered interfaces in our endpoint mapper. The COM protocol, okay. Basically, COM is nothing more than a binary software interface which permits objects to interact with each other. Objects can also interact via network, and this is where the DCOM protocol comes in, because it's distributed component object model. And DCOM, obviously, is also heavily used in Windows. DCOM uses the RPC protocol. We could think about it like DCOM is HTTP and RPC is TCP, okay? And uses the RPC protocol for communicating over the network. The RPC SS service, which is running on every Windows system, is the service control manager for activating and controlling the COM and DCOM servers. And generic DCOM activation mechanisms are very interesting for our research, because in this activation, authentication occurs, especially when Oxid resolution occurs, which is something that Antonio will explain you better, but it's something like the DNS we have about which I talked to you before. It's simply transmitting the necessary information for contacting the endpoint. Here in this very simple schema, we can see how all the DCOM and COM protocol works. It's very simplified. And highlighted in red, they are the components of our particular interest, because in these components, authentication occurs, and we dig deeper in these components in order to capture and relay the authentication. And finally, NTLM relaying. We all know that it's sort of man-in-the-middle technique, where the client thinks he's talking with the real server and such, exchanging the NTLM challenges, and vice versa, the server is thinking he's talking with the legitimate client instead of the attacker's challenge. One thing that we must know, that obviously in NTLM relay, we have to somehow to coerce the victim, which can be the user or the computer, to authenticate. And in our model, okay, no user interaction is needed, which is very, very interesting for the attacker perspective. Okay, I promised it was very short. Again, apologize for my bad English, and now it's up to you.
So in this chapter, we are going to deep in more in what we have uncovered, this new attack surface, about combining NTLM relay with the RPC protocol. So before digging into the deep details, I think it's very important to tell you the how and why we arrived to study such topics. In recent years, me and Andrea and other researchers made a lot of research in the so-called DCOM, DC, RPC local NTLM reflection. This is an issue that has been reported by James Forshaw quite some time ago. I think it was 2015. Yeah. And this is the key component of all the potato exploits. How many of you know potato exploits? Oh, okay. Very good. And this is what trigger all these exploits, so rotten, juicy, rogue potato, and these exploits mainly give you an instant local privilege escalation from a service account to system. Well, we are not going to talk about it in this talk. We already talked about it last year at Hack in the Box. If you want to dip in, you can watch that talk. Today, we are going to present the latest stage of our research in which we achieved local privilege escalation even from a normal user. Okay? The crucial part is the DCOM activation. Okay, and the DCOM activation is performing a DCOM authentication over RPC that is arriving to an arbitrary TCP port. Okay, let's see how this happens, because understanding this will be crucial for the rest of the exploit. Okay, first, the potted exploit, the RPC Trieger, it abuses the standard COM marshalling. The standard COM marshalling, think about it, if you are familiar with Java development, it's a kind of object serialization, okay? So whenever I talk about marshalling and unmarshalling, think about it as a kind of serialization and unserialization. What this exploit does is to craft a malicious marshaled interface, okay? This objref standard is a particular structure that I'm going to detail in the next slide that, think about it, a structure with some raw string bytes. And of course, we are going to fill with some particular some particular values that will allow to poison some answers that we will see. When the privileged server, will perform the unmarshalling, it will find the IP of a malicious Oxid resolver, and this needs to be authenticated. So what happens is that the server will perform an authenticated Oxid resolution to our endpoint. This is still not yet a privilege escalation, because we need to convince a privileged service to do this unmarshalling. How we achieve this? We achieve this with, by leveraging the DCOM activation. DCOM activation is, can be triggered through this call. Use get instance from a storage, in which we can pass this raw string byte, the marshal interface, in a storage object, and the server will perform the privileged Oxid resolution, and the authentication will come to the attacker. Okay? And of course, you can steal this authentication, you will achieve privilege escalation. Of course, all of this nice and convoluted exploit has been fixed, and starting from Windows 10 and Windows Server 2019, it doesn't work anymore. But during our research, we found out that it was a partial fix. And we found a way to trigger the authentication to a remote server. So this is the objref structure. Okay, there are some fields. It's a big structure. The first fields are signatures, flag, ID, and then based on the object we are going to use. In our case, we use always the objref standard. We need to fill with some required values. The first one is the objref standard. It's the object that we are going to use. And there are some values. These values are needed mainly for the intended way is to provide an Oxid, an OID, that will allow the client to communicate with the COM apartment, which has the PID and the thread. It's the internal working on DCOM. And then there is the dual string array that is actually the resolver address, in which you can specify a custom resolver in order to resolve the binding information for the marshaled interface. This is an example of a marshaled interface. Okay, this is an XDump of one of the marshaled interface we use in our exploits. And as the resolver address, we specify the remote IP address, in this case is 10.0.0.30, that will allow to perform an authenticated NTLM, of course with NTLM, in our case, to our remote server. As I told you, this is still not doing anything malicious. In order to make it work as we intend, we need to deliver just the DCOM activation service through the call get instance from a storage. And this call, in order to be activated, we need to specify a CLS ID. That is the class ID, and identify in a unique way COM servers, mainly. For example, if we use the bits CLS ID, the authentication will be performed as system. In our case, we weren't that interested in machine authentication, so all the CLS-ID, all the COM servers configured as network service or local system, even if this is already, could be already lead us to a privilege escalation, and I think that we will do a demo about it. If you combine this with RBCD, okay? During our research, we discovered that there are some particular CLS-ID that, if activated from session 0, so imagine a session 0 is when you, as an attacker, have a SSH shell or a WinRM shell. Okay, you are actually in session 0, or also a task scheduler. If you invoke the activator with one of these CLS-ID, for example, pick a host, you will have the authentication of the first user interactively logged on. So in a certain sense, you are stealing the authentication of another user that is currently logged on your machine. This is, for example, this is the picker host CLS-ID. If you want to identify one vulnerable CLS-ID, you will have one registry key, you can find the IP ID, and from the IP ID you can pivot and you can go to the registry key, and you can see that there is this particular value that say you have to be run interactively, okay? Or if you prefer the DCOM configuration, you can see that the interactive user identity is specified on the object. Very quickly, we had to implement a rogue Oxid resolver to catch the authentication. And Oxid resolution, think about it as a sort of, let's say DNS, but it's not, that allows to the client to retrieve the endpoint information of the COM server. The Oxid resolver is running on every Windows machine. It runs on port 135, and it is exposed through the interface iObject exporter. While we were developing, of course, I'm not going into detail on how we implemented, because it involves middle compiler, client stubs, and so on and so on. While we were developing the rogue Oxid resolver, we were inspecting of some RPC methods that we could abuse. This is the key part of our research. This is the Oxid resolution, okay? A normal sequence. When we trigger a particular exploit, we have the client that is the victim user. That is RPC, to be more precise, it's RPCSS that is performing the call impersonating the security context of the user. And then the server is us, the attacker. When the unmarshalling of the object of the COM interface occurs, a privileged authenticated Oxid resolution came to us. But observing the network capture, we can see that the NTLM sign-in flag is set. So we couldn't do anything with this kind of authentication because the NTLM authentication itself is protecting this authentication. And at this point, we were stuck for like 1 week, me and Andrea, doing some brainstorming, because we tried to do everything on this TCP packet. Okay, we tried to do the worst torture a TCP packets can get, but in the end, we weren't able to unset this sign-in flag. And when we started to understand, when we stopped to look at network capture and we started to look at the big picture, how the system is supposed to work, okay, we understood, with a lot of surprise, that we had some power on the response we can give to the client. The resolved Oxid response is something that comes from the server, so it's under our control. And this is the actual function, and this is the parameters. The first 4 are the input parameters, and last 4 the output parameters. The authentication int allowed us, these are the allowed values, are the authentication levels, okay? And one of it is our interest because define the RPC connection vulnerable to early attacks, okay? The level connect. And in the code, of course, we returned this kind of a provider level because it's kind of downgrade attack, okay? And the second parameter we provide is the Oxid bindings. We, of course, provide the IP of the release server. We are telling the client to use RPC over TCP. And last but not least, we are telling the client to use the authentication provider WinNT. And only with this provider, we were able to unset the signing flag. In fact, these are the kind of authentication provider you can give from this call. WinNT is NTLM, of course. And with a lot of surprise, when the successive call of the Oxid resolution sequence arrived, the signing flag is not set anymore, okay? So this was a bingo for us because the rest of the exploit was more of just a fun ride. But this is just a trigger of the authentication. In order to achieve some privilege escalation, we have to relay this authentication. In a normal scenario of an NTLM relay, there are usually 2 main phases. The one in which you have the coercing method, so the client, and the second is the vulnerable server, so the one that you do perform the man in the middle. For example, for SMB protocol, if you read a file over a share, you will trigger an authentication. Or without the user interaction, you can, for example, make Windows Defender scan a share for you. You will get an authentication system, for example, or spool sample and petit poton. And then you have the part of the server that received the authentication. It's the privileged resource that will perform the operation on behalf of the user. You have file sharing, you have LDAP, you have HTTP, you have also RPC, vulnerable servers, okay? For example, the task scheduler and the spooler service. But what about the client authentication of RPC? That was the case in which we are. Well, we tried to find something in the state of the art, but we didn't find anything. So we had to find something else. Of course, RPC, relaying to RPC was not interesting because, as I said, vulnerable RPC servers are already a vulnerability. So we tried to understand, okay, what if we can relay RPC to another protocol like LDAP? This would allow us to expand this attack surface very much. So what we did is to understand if this is possible. So if an RPC authentication going over RPC can be relayed to HTTP, for example. So we set up a scenario from an RPC connection to reading a file over a protected HTTP server, okay? If you want to trigger a RPC authentication with NTLM, you can write some code, but if you don't want to write some code, you can use RPC ping, okay? This is a built-in utility that will allow to trigger RPC authentication with NTLM, okay? So this is the scenario that we set up. Okay, we have, of course, it's a man-in-the-middle attack, but it's a little bit weird because the 2 protocols are different, okay? So on the left, we will have RPC, and on the right will be HTTP, okay? Could seem strange, but it works, okay? So in the middle, we have the attacker. On the left, there is the victim, and on the right, the web server. The attacker triggered the RPC connection, okay, with the potato exploit, for example. And then the victim will perform type 1, okay, NTLM type 1 to the attacker, man in the middle. The attacker will instantiate a new TCP connection, HTTP connection, and will embed the NTLM part, okay? So the web server, it doesn't even know that the NTLM authentication came from RPC, okay? okay? It just say, okay, you are authenticating with HTTP, you are good with the NTLM, okay, way to go. And of course, the man in the middle, the attacker, so what we implemented, it's of course unpacking the HTTP authentication, the HTTP packet by extracting the NTLM authentication. And of course, this flow will go. And in the end, the attacker, the web server has authenticated the attacker and is being able to read the secret TXT contact. So what we can learn from this experiment, that RPC to HTTP, RPC to LDAP, RPC to SMB cross-protocol relay works. We had, in our final scenario, we also had an additional layer of relay, so RPC to HTTP and HTTP to LDAP. Yeah, the authentication is doing a lot of travel, okay, but it works. This is just that allowed us to reuse some code from NTLM Relay X, okay? What we need to consider in our experiment, in our findings, is that the thing that we need to take care of is the authentication level, must be connect, otherwise RPC won't allow to relay NTLM authentication, and we need also to deal with NTLM mitigation itself, with the authentication protocol itself mitigation, like signing and make. And remember that only some special SSID allow to unset the signing flag. And now I will pass the ball to Andrea.
Thank you. Well, can you hear me? OK. This was great, but we had a problem, because as you can imagine, getting a shell in session 0 is not so a common task for a standard user. So a very more common scenario is when you land on a machine where the remote desktop services are running and where multiple users are connected, okay? So it would be interesting to relay the authentication of another user connected on the same machine by simply specifying the session ID. And it would be very easy then to capture all the authentications. But the session moniker, which is the component which allows the activation of objects on per session basis, could not be combined with the co-create instance from my storage, which is the activation call that we used. So no way, but not exactly, because sometimes later, James Forshaw did some research based on, also inspired by our remote potato 0, and discovered that there were some undocumented calls which permit to specify the session ID before activating the object. So we quickly implemented this function in our remote potato. And with this tweet, we finally announced that cross-session was possible also in our exploit. And in this snippet, you can see the code which we implemented in a new function. So in the activation service, we can specify the session ID, and then we instantiate the object via this undocumented standard get instance from my storage call, which permits us to activate an object on a different session, not only the first session where the user is logged in. OK, this is what we call the big picture. I try to keep it as simply as possible. It's not so complicated. OK, let's start from the beginning. So we have a machine where a domain administrator is logged in. Then we have also our attacker machine, which must be on the same network, which must be reachable on port 135. And from this machine, we have a shell on the victim machine in whatever session. We copy our exploit on this machine and then launch it, specifying the CLS ID and the session we want to interact with. When this occurs, resolve X, as Antonio explained to you, when the activation occurs, a resolve Oxid request is made to our local server, okay? Our local attacker machine. We intercept this request and we simply forward it to again to the victim machine where our fake Oxid resolver is running, okay, by specifying the IP address and the port where the fake Oxid resolver is running. Once we get this request, our fake Oxid resolver will produce the correct response, which will instruct, again, the trigger to contact, again, our the victim machine and to activate the object. When he needs to activate the object, the first thing he does is to bind to the IREM unknown interface. And by binding into this IREM unknown interface, an authentication will occur. We then simply catch this authentication, relay it to our local RPC HTTP server, and then relay it again to our attacker machine where also NTLM relay is running, and then finally relay it to our target service, which can be the SMB, LDAP, HTTP, etc., etc. Okay? I will skip these two slides because I think we don't have so many times, but it's just a side note. Maybe if you are interested, I will explain to you later. So now it's demo time. So Antonio will show you the first two demos, and if we have time, I will show you the third, okay?
Okay. So in these demos, we are going to show Remote Potato 0. It's our exploit. If you want to know the story on how we choose the name, please later approach us and we will tell you a funny story. In this demo, we are going to see a privilege escalation from an unprivileged access to domain admin, okay? So I'm going to show a Linux machine which the attacker has left the compromised machine Windows, and on the right, some helper tools. Okay, so on the left, the attacker has this unprivileged access, normal user. It checks his privileges to the domain controller. He is in the domain users group. Then he checks the IP of the compromised Windows machine. Then check who is currently logged on. There is a user called domain admin in session 2, and himself logged in session 3, normal user. And then you want to steal this authentication and invoke remote potato 0. It specifies some flags. The X flag is the remote Oxid resolver, IP, that is the 10.0030, the Kali Linux machine. It's also the relay server, the same machine. Then we run the network redirector, socket, to redirect the malicious Oxid resolution back to the Windows machine. And then we use NTLM relayX with the parameter targeting the domain controller LDAP server, 10.0088, and performing the escalate user attack, so normal user becoming enterprise admin. The server is running, the relay server is running, we choose the cross-session activation, all of this stuff that we explained in the course, okay? So we can see that remote potato 0 spawned the object in the session 2, the domain admin session. We used the Picarossi LSAD, we received the relay authentication, we connected to NTLM relayX server. And on NTLM relayX, we can see that the authentication came as domain admin, okay, the type 3 as domain admin, and the user, normal user, has been added to the enterprise admin group, okay? So it's a straight privilege escalation to a domain. And now if we check again our privileges by querying the LDAP server, we will see that we have enterprise admin privileges. Okay, the second demo, it's when you don't have that much network access. You can also steal the hashes of the NTLM authentication, and then we can offline crack these hashes, okay? It's basically more or less the same scenario, okay? We are a normal user. We check our domain groups. We are domain users. We need to get the IP address of our targeted machine. We see that there are 3 users logged on: ET user, session 82, domain admin user in session 4, and normal user, ourselves, in session 5. Of course, think about it in a terminal server, okay? This is the most common scenario that you will have some problem. And then we run remote potato the module 2, that is the hash stealer. We set up all the helper tools for the Oxid resolution forwarding with socket. And then we specify the domain admin for session ID, okay? And then we are able to get this hash that is technically not a hash. It's a combination of response and anti-proof string and so on. And basically, we are able to, this is the resolve Oxid to call. It's very similar, but it requires more job to do. Here is the final hash of domain admin, and of course, this you can be cracked offline if the password is weak enough. And then, of course, we can steal also the hash of the other user, IT user. And that's all.
Okay, we can skip the next two. The next. Okay. Mitigation. So we opened the case with Microsoft, and after a long debate, even if they considered it an important privilege escalation, they finally decided not to fix it because the servers have to defend themselves against NTLM relay attack, which is also true. So what can we do in order to avoid all this black magic? Well, NTLM is deprecated protocol, so you could think, okay, disable NTLM, but disabling totally NTLM is very, very disruptive in a common scenario. So I would not recommend it. Maybe you could put the most sensitive users in the protected protected users group, which will disallow also the NTLM authentication for this particular users. But we have another problem. This is a recent discovery from James Forso. I don't know if you read this post, but he demonstrates that it is possible also to relay Kerberos authentication. So I think he opened a Pandora box and finding a totally new attack surface. So what can we do? Well, the right way is what Microsoft recommends. So enable signing on SMB, enable extended protection, channel-based token, and so on. So hardening is possible. You just need to configure it, but to monitor it before, because you can have old legacy application will then have problems to work. Otherwise, you could also use a free patch for remote potato, which is delivered by Zero Patch. We will inhibit the remote potato exploit. So, conclusions, very quickly, we have 1 minute, okay. NTLM is not that bad. It's simply old. It's like me. It's old, okay? So, poi, other question, do not blindly trust the multi-user model and the multi-user protection, because as you could see, we can instantiate an object in another session and then become very, very dangerous. One fix does not mean without risks. And then finally, the whole new thing, whether this was my personal idea, is that all the potatoes and TLM and relaying, not NTLM, relaying, generic relaying, are still alive and clicking. So the special thanks goes to James Forso, all the potato developers, the Impact developer team, and obviously BlueHat organizers. I told you quickly, I told it BlueHat, okay? Well, that's all. I hope you enjoyed our talk. If you enjoyed it, share it. Otherwise, share it only with us. That's all, and thank you again.